Hello everyone, another new day, another new concept mixed with a spicy story. So many of us always wonder while we study Thevenin's theorem, why do we ever need to convert a big circuit to a Thevenin's equivalent circuit? What is the benefit of doing it? So practically we have to think of what is the application of actually converting a complex circuit into a short and a small Thevenin's equivalent circuit. So here I have come up with a concept. Now we all love Maggie. It's the favorite food. Everyone loves to eat Maggie. And Maggie has come up with a very good and an instant technique of making noodles in just 2 minutes, right? So whatever preparations it has to do, whatever raw material is required, that all has been pre-processed. Now, what do you do? What do you try? What do you experiment with Maggie? While you cook Maggie, at times you add a little bit of spice, at times you add a little bit of seasoning as per your taste. So Maggie becomes a new and a different kind of noodle for you, right? So this is a favorite food for all the new timers who are cooking for the first time and for all the hostlers, right? Now, let's come back to our electrical engineering concept of Thevenin's theorem. Now, why do we ever convert the entire big circuit to a small and a sweet Thevenin's equivalent circuit? It is because a complex network, if you are always going to make some calculations on it, so it would be a tedious task to calculate it from the scratch, from the start level. But if you have something equivalent of that circuit, which is in the shortest or the simplest possible form, and probably you may keep on changing the load. Okay, you can keep on changing the value of the load or the nature of the load, make it resistive or inductive resistive or capacitive resistive, and so on. So you will be able to understand and analyze the performance of your big circuit. So that is why Thevenin's equivalent circuit is very important to us in practical use. In a similar way, like Maggie has given you the pre-processed noodle to you, and you keep on adding some spices and seasoning to it, and you quickly know that how Maggie will taste, how much better it can taste while you are adding certain spices to it. So in the same way, if you are going to convert your entire big circuit into a smaller Thevenin's equivalent circuit, that means that your calculations will be much simpler, it will be faster, and they will be so fast like 2-minute instant noodles which Maggie is offering to you. So I hope that this small concept of Maggie has given you an idea that why do we ever need to convert the big circuit into a Thevenin's equivalent circuit. Now here I would like to conclude one important point here, that Thevenin's equivalent circuit and Norton's equivalent circuit, they both have the same purpose. Okay, one is converting the entire circuit into a voltage source with a series resistance. The other one is converting it to the current source with a parallel resistance to it. And both these equivalent circuits, they both are dual of each other. So depending on the nature of analysis you have to do and the nature of the circuit, you will decide whether you would like to convert your big circuit into Thevenin's equivalent circuit or into Norton's equivalent circuit. So I hope this small concept will make things simpler in your life. So thank you and happy learning.